Yeah, what's up my beautiful people? Trust you are doing very good out there. So in the last video we were working on how to repair this particular amplifier, which if you've not watched that video, do yourself a favor, check my playlist, go and watch that video, because in that video we've been able to troubleshoot this particular segment, and we're very sure. So today we want to take our troubleshooting to this segment till we'll be able to fix everything 100%. So if that sounds like something you really like, why not give this video a thumbs up? So, and also don't forget to like and subscribe if this is your first time on this channel. Alright, let's continue today. So in today I want to look at this segment. If you look at this this segment we have here, if you look at it, this is let me show you where you can see it, extension loudspeaker. So what this side simply means is the output coming out from display, because if you look at this wire I have here, you know, this is a combo, this is a side that will be connected. Let me show you the other wire here. You can see this is my other end of my speaker. The box you are seeing here, the end, this is my speaker. Now if I read my speaker, it must show continuity, except if it is not good. If I read it now, I must hear a continuity sound. Oh, my meter is down. Let's check. So put it here. 1 year, 1 year. If you don't hear any sound or any reading, that means your speaker is bad. So for my speaker, it's still okay. That is another part. So this, my speaker extension is sending there. So in case I want to add more speaker, I can easily plug it from the back and send out. But that is not where we are doing. At least from the troubleshooting, we've been able to deduce that that speaker is also still good. The transformer is good. In the last video, we've been able to decide that. So today, let's now check other parts of maybe there is likely any fault. So let's remove all this. I'm removing this, I'm removing this, and I'm removing this too, so that we can see everything going on very, very well. Alright, let me remove this guy too. Don't forget, like this video, because I'm showing you everything you need to know on how to start your electronics journey for free. Alright, so don't forget to remove our fan here. AC supply, our 12 is here, our 17 is here, our 40 is here, while our output is here. So don't forget that. And whenever you want to disconnect, if you are not sure of what you are doing, do yourself a favor to label it. Maybe you put a star shape here, you tag it here, a rectangle, so that you'll be able to know where you remove it from. Because let's assume this place is 17 volts now, it's definitely 17 and this side is 40. Imagine you take the 40 to 70, you know what will happen, because this is 40 now, and this capacitor that is responsible for the 17 volt, you can see the rating there is 35. So if I mistakenly mix up the voltage of 40 to 17, you see it's higher than 80 to blow it up. So always take note of that. If you are not sure, if you cannot really cram, or let me say cram for a beginner, if you cannot really cram where you remove it from, just tag it. Just find something that you'll be able to, let's say a barrel, you just put a shape here, you put it here, so that you'll be able to identify where you remove it from. That's just, by the way, an advice anyway. Alright, so this is the segment we want to take our troubleshooting to know maybe there is any problem here. For this side, we don't know, but for today we want to look at this side, maybe it's working perfect or not. So to do that, let me see what we should do. We will likely have to remove this guy, so let's release this very fast. Let's do that, because I want this to be a, no, let me go. Part of the video. Okay, Jero. Alright, so we'll lose this. I'm losing it so that you see all the entire process. So you see, for me to remove the heatsink, I'm coming to the back, so you not think the heatsink will come out by itself. And in case you lift any part and it's not lifting, that is to tell you there is a bolt behind. So always take note of that. That's why I did not skip this area, for you to see the entire process. Alright, so we have our 3 bolts, just 3 holding the heatsink. And I believe at this point, let me just, for heatsink, I will explain what heatsink does. Heatsink is very, very important, especially when you are dealing with parts that has transistors. Heatsink is very important, because what your heatsink does is, transistors by default, because they are the one generating the wattage, you know, the sound supply you are getting, they are the one responsible for it. So they get hot over time, because they are doing a very great job. So definitely you expect it. So the one I have here, so unfortunately my camera may not be able to capture the numbers here, because My camera is not too sharp, and don't forget, in case you feel like supporting, because I plan on getting a very good one, so you can, there is a link in the comment in the description. Is a show me love link, so you may decide to support me in getting a very good one there, so you can check the description. That is by the way, thank you in advance. Okay, but let's manage what we have for now. So this side, what we have here is 2 SA. I don't know if you can, let me see, maybe you can manage and see it a bit. Sorry, the camera is so terrible. Alright, let's just manage it for now anyway. So you can see this is 2SA19. Just trust me. If you cannot see, trust me. Alright, this is 2SA1943. This is another one, 2SA1943. This is 2SA1943, 2SA. So 2 aside, that is the NPN and the PNP. And if you cannot decide which one it is, feel free to ask the question in the comment section. If you want me to make detailed video on how to identify PNP transistor, NPN transistor, and the transformer and the rest, I will definitely do that in the next video. Provided I receive a lot of requests on that, I will definitely do that. Alright, so we want to troubleshoot these guys. We've been able, all these other side have passed our test so far. We've been able to deduce that they are not the source of our problem. So likely problem is here. Now this is the amplifying section. Now this section you are seeing is the amplification section. We have the preamp and the main amplifier section. Why this side still has to do with the power section, because what is coming from the transformer will comes here. Remember, it's still in AC. What your transformer is sending is AC, but when it gets to this point, it will enter this place, then your diode will convert it from AC to DC. I believe you really understand that now. To convert it from AC, the AC, but you know what your transformer assembly did is it convert the voltage from, because the initial voltage coming, sorry, I'm saying 230 volt input, because in my own part of my country here, our voltage rating is around 220, 232 volts max. You understand? So for those of you that your voltage rating is around 110, yeah, I know a lot of places use 110. So let's say your voltage is 110, definitely your transformer will step it down to maybe like 40, 30, and the rest. You understand? Same thing is applicable. So for my side, we are using 230. So yours, if it is 110, still the same process is applicable. You understand now? So your AC, what is coming through the second side is TAC. So once it comes in, at that point, your component cannot deal with it. They are still very high. You understand? So we need something to really convert from that AC to DC. That is, AC simply means alternative current, while DC means direct current. I believe you fully understand that now. Okay. Now, first thing to do is, whenever you are dealing with stuff like this, first thing to do is use your eye. We call it visual inspection. So check through your board. You know, for transformer, it may not burn physically. You understand? In terms of seeing a serious burn, why sometimes you see a serious damage on it. But at times some of them will give you the sign that they are faulty already. Like for example, capacitor. Some of your capacitor may be swollen. You understand? Look at this one now, still very fresh, looking okay, no swollen sign. So check all your capacitor. You can see everything still okay. So from this, I can still assume like 50 to 60% that my capacitor are good, although there are still some that will look fresh. Well, they have injury already, while some are even completely dead. You understand? But for now, my capacitor still looks good. If you look at it very well, you see they look good. Now let's look at our diode. Our diode still look good. I'm not seeing any burn, although we still read them. Our resistors still look good also. You can see my resistors and the rest. Everything looks good, except look at this guy here. You can see this resistor. You can see the sign on it. So this one has already given you a red flag that is having injury. If I look at all this side, they are looking. So this resistor is giving me a sign that is sick already. Let me show you so you see it better. Okay, this is much better. So this resistor is 40. Even though if it is still good, I would prefer to change it because it will still get damage along the way. You see this other one, you can see this is the next stage, which is visual inspection. You can see this guy is 42. I don't know if you can see what I'm saying. Okay, this is better. Yeah, don't forget, give this video a thumbs up if you are really learning from it. You can see this guy is 42. So how many resistors have we seen? We've seen one, we've seen two. You understand? So let's see if we can see more how this small one looks still okay. This guy is still okay too, hopefully. you can see there is another resistor inside this inductor. Yeah, you can see it inside. That should probably be 100k, but still okay too. Still okay, hopefully. Anyway, based on visual inspection, looking okay. Then some hidden ones here too, they are still looking very okay. So for the resistor so far, what I can see from visual inspection is these two, 1, 2. Now let's now check our main diode. Let's look at this big boy here. Yes, you can see that there is a serious problem here now. This is a diode, but although different from these small ones, because these are just single diode, but this one is a 4-legged diode. That is, it is 4 like my hand this way. The middle, the 2 middle will be the AC, while the plus and minus will be by the side, the polarity, you understand, and the DC output. So this will be what, so the 2 for the voltage that is coming here now. For example, let's say this is what is serving the diode. This one will go to the AC, this one will go to AC, this one is the black is going to the ground. So then it will give out DC format at the various edge. It's because my camera may not be able to pick it. Let me see if we can manage a bit. Just bear with me, okay? This seems to be better, luckily. So you see the middle is AC. So that's 2 legs. They are the one receiving the voltage, while this side is the negative. So you can see this is the positive side. So for those of you that may be doing a very DIY video, or maybe a particular tutorial, maybe not tutorial now, let's say you're working on a project to build maybe a very 12 volt, you can easily from your transformer just connect the AC here, then automatically you have your DC at the various edge, instead of combining 2 pieces of diode, although they may be expensive than the tiny ones like this, but that is just a fast way instead of combining 4 there. Is that clear? Alright, so from this video we've been able to deduce that 2 resistor gone, another one here gone. This guy, the diode, you understand, the diode is bad also. This diode is bad. So from this, so when you see a diode is bad, don't just change it and you just power it on. No, check around, be very sure that there is no other. For example, let's assume one of these guys has born now. If I change this, there is high probability that it may backfire and burn it again. So you have to check every other part and be very sure. So in the troubleshooting, our transformer, in the last video, the transformer passed the test. And today we've been able to deduce and be able to find out this resistor is bad. This one is bad. This diode is bad also. Our capacitors are looking very good. And another thing to really check out for is your regulator. This particular one here is tip. My camera may not, it cannot be able. It cannot, but you can see the name there, 41C. That is tip 41C. This is 42C. And this is 7815. The 7815 is a 15 volt regulator. That is, let's say the 17 volt is coming on it. What it will do, it will drop it to 15 volt. That is what a regulator does. Like for example, this one, although it's not there, I guess the factory decided to put a regulator here before, but maybe they were able to realize they don't really need the 5 volt edge. That's why they did not really later put it here. But assuming they put it here, this one is meant for 7805, which is a 5 volt regulator. So let's say 20 volt is coming on it, it will step it down to 5 volt. That is how powerful this little guy is. So in the course of the troubleshooting, we can check for these two, although, but let me just do a very quick test so that we see how to check for it, because there is no way to power it up without doing that diode, without using that diode. And since we are not sure all the fault, replacing the diode and just firing it up can cause a big problem. So put your multimeter in continuity. The middle is always the ground. If you touch it against this side now, it's ground. Let me see my camera so you can see it better. Don't forget, like this video if you find it very helpful, and if you decide to support me in getting a good camera, feel free to check it in the description. It's a show me love page, so you're free to donate anything you want. So the middle is always this ground. You can see it, it's the ground connection there, while the other side is the one that will receive the voltage input. You understand? So this is like voltage input, ground. This will now be the output. So let's assume a 20 volt is coming here. You know, this is a 2 volt coming here. The main one will come here, then the ground will be here, while this will be the output, and it will pick up. So the both of them will share the same ground. I believe that is very, very clear. So this is the ground now. So in case I'm testing, I may not likely touch this place. So let's check. Maybe there is a bridge between our ground and our input. So you can see, let me show you my meter. This is a quick way to test maybe it's still good or not, instead of doing trial and error, because it's very okay, it's very necessary you check it, because any part that requires this 15 volt, if this is 40, then it will definitely not come up. I believe you find this very helpful. Feel free to subscribe. So let's check it now. So to now test it, just remember the middle is a ground, so just use it and touch this first tip. Touch it, check your meter, you see it's reading. That is to tell you that the input side and the ground is still perfect. This is for my ground, this is for my input, which is still okay, giving me a very good amount of resistance. Let's see the output. Still very, oh, my meter is sorry. So let's come on back. Let's check the output side. You can see it's giving us reading. So this our K7815 is still very okay. Assuming we are getting any bridge between the output, the input together, that is to tell you this is bad because there is a short. And let's read the input output against each other. You can see it still working perfect. So that is to tell you that this regulator is still very much okay. So we know now our problem is not from this guy. For this tip 4143, let's read it from the back side here. And to do that is very simple. Look at it. You see, let me show you my meter. There must be no short. That is what we're after. You can see it now. Oh, my meter. Look, just feel free to check the meter. This is the tip of the 4142, tip 42. So you can see it's giving me reading now. No bridge. Let's check against the second one. If it is not giving this way, then interchange it. You can see it now giving me reading. No short circuit. This one, the same thing. Other side, same thing. You can see. So this one is still very okay too. I just want to be sure that all these transistors are okay. This is okay. This is okay too. You can see okay. So now we are very sure that because it's very important, because if you just go and change this rectifying diode straight, you may damage a lot of things. If this guy is 40, it may backfire, you understand? So this is still very okay. Sorry, this the voltage regulator, the tip 41 and the tip 42, the two of them are okay. All our transistors still look, all our diode look very good. And let's look at this diode, maybe it's good or not. Okay, this video is getting too long, but sorry it's too long today, but I felt you really need a very detailed and helpful video like this. If you don't want my videos to be short, feel free to drop it in the comment, no problem. I'll make it short, but you may not get a full detailed explanation this way. So remember a diode that allows the flows of current or voltage in just one direction. So if we can get reading from both directions, that is to tell you this diode is bad. The reading, although there is no physical damage on any of this component, but it's good you cross-check well, because sometimes some of them will look very good, but unfortunately they are bad. You understand? But you see, we've tested this, they look good, all our capacitors look good. So this is the black side. You can see it, it's giving us reading. Let's now interchange it. It must not read the other way. So sometimes it can happen. You can see this one is reading in one way, but the other way not reading. But if peradventure is giving you reading, don't assume it's bad yet. What you need to do is just desode one of the leg. Desode it. Once you desode it out, then read it properly. You'll be very sure 100%, because sometimes they tend to react based on the surrounding component. So sometimes you may see a diode reading this way, the other way is still read, you understand? But that doesn't bother. If it is giving you short both way, then it's bad, you understand? And that is a quick tip, by the way. So you see this is another diode. This is good. Let's check the back way. Good. The back way, you see, this is what I just explained. Now you can see it now reading both way because of the surrounding component. Is another close by diode, so it's picking the reading from there. So but this is still good, I'm very sure of that. This is good, this is good too. So this is good. So without wasting time, I'm sure, because as you do this over time, you'll be able to predict very fast. This entire segment, with what I'm seeing here, everywhere still looks good. So the fault so far on this segment is this diode, this main AC that is responsible for this 40 volt. These ones are the one responsible for this 17 volt and this 12 volts, you understand, for this segment. So this is the guy we need to change. Then our resistor here is bad. Now let's even check the resistor. And funny thing about this resistor, it may be even giving you reading and be working, but whenever I'm working with stuff like this, once I see a need to sign, I will remove it totally. So we are not sure of the exact measurement of the resistor, so let's start with the very high one. Let's just start with maybe 2 mega ohms. Let's put it, I can see showing me 8, so that is to tell me it's low. So you can see now, so it's a very small resistor. Let's go to 2k. You can see it. Let's go to 200 ohms. Now let's read. You can see this is 30.3, so it's just like a 30 ohms resistor. It's a 30 ohms resistor. Let's check this one. This one is more than that. That is okay. Stay between the range. This is 5.8. Let's just say maybe 6 ohm or 5 ohms resistor. You understand? But what we are not concerned about with the radio. I just want to be sure that it's still good. This is good too. This is good. Let's see this guy. You can see what the rest are giving, and they are the same thing. This is giving us sorry about my meter screen. This is 5.9. that is approximately 6 ohms. But if you look at this now, see what it's giving us. It's 3.3, so it's weak already. But even though it's still good, I will change it with this condition I'm seeing there. So this is a bad one. We'll change that. Then this, you can see now, this is 98. This is an 100 ohm resistor. You can see it here. And this one is 30.8. This is like 30 ohms. Why this one? They are the same thing, but this one is giving us a fake reading already. But by the way, it's advisable you change it. You can see the sign on it. You change this, you change this. So you can just pick up the color code there. Then there's an application you can type it to, so you'll be able to get the exact value of it. Then for this one, let's see if this resistor is still very good also. You can see this is a 10 ohm resistor, so this one is good. So from what our tests have shown so far, what is just bad is just 2 and 3. This is bad, this is bad, then this is bad. I guess that is a 4th for now. So watch out in the next video where we'll change those components and we'll be able to see the end result. Do wait to like and subscribe to my channel, and let me know what you feel in the comment section. Let me hear your thoughts and the rest. Thank you so much. Thank you. See you in my next video.